Hi champ, welcome into another amazing session. I am Master Teacher Shubham Gupta, and in this class we are going to discuss about the nature of decimal expansion. So champ, in this class we are going to talk about the non-terminating and terminating decimal, and after that we will see the nature of the decimal expansion also. Let's get started, a very important topic for your exams. So champ, let's see some of the rational numbers. So let's say we have 1 upon 2. 1 upon 2 can be written as 0.5. 1 upon 3 can be written as 0.3333 up to infinity. Whereas 1 upon 5 can be written as 0.2. 1 upon 11 can be written as 0.090909, which is not going to end. 1 upon 30, same, we can write in the form of decimal form, which is not going to terminate, which is not going to end, right champ? Whereas we can see 1 upon 17 again, which is not going to end. So we can see over here that some fraction are getting end, right? And some fraction are not ending. So can we predict something for it? Let's see, let's figure it out. So champ, as we can see, for what denominators do the decimal expansion terminate? We can see that some of the fractions, some of the decimals are getting terminate, whereas some of the decimals are not getting terminate. So what denominator do the decimal expansion terminate? Let's figure it out. So champ, where I have 1 upon 2, 1 upon 5, these fractions, the decimal form of these fractions are getting terminate, right? And whereas now we can see, guys, on the basis of the denominator, can we figure it out that which decimal expansion is going to terminate and which is not? Let's see. So champ, let's say we have some fractions, okay, and let's do the prime factorization of every denominator. So after the prime factorization of every denominator, let's figure it out that which of these fractions have the decimal expansion terminating and which one has non-terminating decimal expansion. So champ, we can see the 13 upon 8, it is going to terminate. That means when denominator of the rational number is of the form of 2 to the power m, my decimal expansion is terminating. We can see in this case, when the denominator is in the form of 5 to the power m, my decimal expansion is terminating, right? We can see in these two examples, 11 upon 20 and 23 upon 50, where my denominator is in the form of 2 to the power m into 5 to the power n, my decimal expansion are getting terminating, right? And whereas the cases when the denominator is not of the form of 2 to the power m into 5 to the power n, my decimal expansion is non-terminating, right? So now let's see the nature of the decimal expansion on the basis of the denominator. So champ, whatever we have seen, that when the denominator is of the form of 2 to the power m into 5 to the power n, in that case the decimal expansion is terminating, right champ? And we can see that when the denominator is not of the form of 2 to the power m into 5 to the power n, in that case decimal expansion is non-terminating. Very important concept champ. I hope it is clear. Very good, excellent. Now let's see some question on it, how to identify that whether the decimal expansion is going to terminate and when it is not. So let's say champ, we have one question and some fractions are given to us, some rational numbers are given to us, and they're asking that which one of these will be terminating and non-terminating. What to do? Simple, the prime factorization of the denominator. Okay, so we can see over here, when I am doing the prime factorization of the first one, the prime factorization is 2 to the power 3. So it will be terminating. You can see, guys, right? 12 upon 20. We can see very easily the prime factorization of denominator satisfying the terminating condition. The last one, the prime factorization is not of the form of 2 to the power m into 5 to the power n, and that is why this is non-terminating, right? So now champ, what we have seen over here, that we can see in one more example, let's say 39 upon 60, right? So now champ, 39 upon 60, after doing the prime factorization of the denominator, we can simply see, right? After finding the value, we can see that this is terminating. But if we will see the prime factorization, it contains 3 to the power 1. So it should be non-terminating. Then why it is coming terminating? Right? My denominator is not of the form of 2 to the power m into 5 to the power n. Then why it is coming terminating? Let's see. There must be some other condition also, right? So now champ, we can see 39 and 60. Both the number has one common factors. 39 and 60 has 3 as the common factor. So if I will cancel out the common factor, my denominator will become of the form of 2 to the power m into 5 to the power n after cancelling out the common factor. So what does this mean, champ? This means that a very important condition. Always express the rational number in its simpler form. That whenever you are judging that whether any number will be terminating or not, make sure your numerator and denominator are co-prime number. Only you can decide that whether the decimal expansion will be terminating or not. A very important point. Okay? Very good, chap. Now let's see how to find the number of the digits after decimal. Okay? In the case of terminating, obvious. So let's say it's a very interesting problem. I know that. So now let's see a very interesting property to find out the decimal places after the decimals. So champs, let's see some examples. And first of all, remember that convert every number in their simplest form. Okay. Okay. So now let's say we have 22 upon 32. First of all, we have to make sure that numerator and denominator does not have any common factor. So these two have one common factor 2. So we simply cancel out 2. Now my denominator is what? 2 to the power 4. And I can see here that my decimal expansion is terminating after 4 decimal places. Right? Whereas we have seen over here, guys, what is the relation between this? The power of 2 is also 4 here. Right? Very good. The same thing we have seen. Now guys, let's see one more example. 85 upon 125. Right, champ? What we do? Simply cancelling out their common factor. We are getting 0.68. Right, champ? So now we can see here the power of 5 is 2. Right? Power of 5 is 2. And there are 2 decimal digits here. So some relation is there. Okay, let's see. Let's see one more example. Let's see 12 upon 200. After cancelling out their common factors, we are getting what? 2 to the power 1 into 5 to the power 2. And we are getting 0.06. So champ, here we have only one factor of 2 and we have here 2 factors of 5. Right? 1 factor of 2 and 2 factor of 5. And we have total 2 decimal digits also. So what we can say from these kind of examples, we can say the very important property, champs, that the number of decimal digits is what? The number of 2s or number of 5s, whichever is the greatest. Okay, very simple concept. I hope it is clear. Very good. Excellent. Okay, champs, so now let's summarize our class, that what we have learned in this class. So champ, in this class we have seen that if we want to find out the denominator expansion, right? The decimal expansion of any rational number. How to do it? Simply factorize the denominator, but make sure that numerator and denominator both are co-prime. And if the factorization of the denominator is of the form of 2 to the power m into 5 to the power n, then my decimal expansion will be terminating. Otherwise, it will be non-terminating. Very simple concept. And after that, we have seen, champ, right, that always simplify the rational number. Again and again, we are repeating very important property. Okay. After that, we have seen how to find the number of decimal places. Very simple. The number of 2s or the number of 5. Which one is the greatest? That's it. I hope it is clear. Very good. Excellent. So that's it for this class, champ. I hope you enjoy the class. Practice hard and stay curious.